this one, okay? But we don't want that to happen. However, everything's still solved as usual, just like we would an equation. So I'm gonna start here on the left, and yeah, just isolate my negative 2x's, so subtract 5 from both sides. So drop my negative 2x. You could have zeroed out the 5s first as well, but whatever. So negative 2x is greater than 17 minus 5, boom, 12. Okay, and yes, this division right here of negative 2, coefficient, yeah, that's going to flip this inequality. So now x is less than negative 6. Now for and statements, we don't usually need two inequalities to represent an and statement. We only need one, which we will show hopefully by the end of this problem, okay? But that solves that first one there on the left. Next one here on the right, distribute the 3. 3 groups of 1x's would be 3x's, and then 3 groups of negative 1 would be negative 3. Is less than or equal to 3. Well, solving for x, add 3 to both sides. Drop your 3x, that zeroes out. 3x now is less than or equal to 6. Divide both sides by 3. That's positive, so we don't have to worry about flipping the inequality. X is less than or equal to 2. Okay, now, again, we'll see what this looks like with the and statement, but I can't just put an and statement between these, okay? As convenient as that be. Let's look at see what the graph looks like. So what do we got? Negative 6 and 2. So there, 0's in the middle, negative 6 over here, and then 2, we'll say right there, okay? All right, let's start with the red one. Negative 6, that's an open circle because it does not equal that negative 6, just less than. This one's not eating the x, so this line here will go to the left. And then the purple one, x is less than or equal to negative 2, so that'd be a closed circle at 2. And it is not eating the x as well, so this one goes, I'll try to do that a little bit better. I think that, I accept that. So we've solved it. Here's the graph, but there's only one part of this graph that you need, right? Because we're looking for an intersection of the two lines. And while I kind of draw them apart, I think of it more as where they become, I guess, parallel or where they overlap, right? However you want to think about that is completely up to you. But the real graph would have to, you'd have to have a circle right here and then just everything to the left. Meaning, really, that purple one is kind of obsolete right now, okay? And that also means that in terms of the two inequalities we found, we don't need this one. Because everything to the right of negative 6 would be a false statement for this and statement. It has to be not only true for one, it also has to be true for both. And it's true starting at negative infinity, and then it stops at negative 6. Now, whether we use a closed parentheses here or a bracket depends on if this circle is closed. Because we know the purple one, at negative 6 is going to make this purple inequality true. But will it make this red one true? No, and it has to be true for both. So this is going to have just a closed parenthesis. So we get this interval, and then the graph would just be the orange line right here. I kind of feel compelled to erase the purple line. Something like this, okay? So just the purple, and then the inequality is x is less than negative 6.